Good morning, dear students. Today we are going to discuss about the important aspect of carboxylic acid chapter, which is the reactions of carboxylic acid. In this, we will see the first part of these reactions among the various reactions. So we'll see how this carboxylic acid will react. Please click the subscribe button. So to understand the reactions of carboxylic acid or to understand how this carboxylic acid will react with others. So as we know that carboxylic acid group have two functional group or two parts. One is the carboxylic acid group, carbonyl group, which is an electron rich oxygen and which can electrophile act as a electrophile. Whereas the second part is a acidic OH, which is a easily react with the bases and eliminate. And third part is a electron deficient carbon target by nucleophile. So we can say that in carboxylic acid, three parts or three positions or three regions are available for reaction. One is the carbonyl carbon, which is an electron deficient carbon and act as an electrophile. Whereas the carbonyl oxygen, which is electron rich and which can be targeted by electrophile and act as a nucleophile. The third part is the OH proton deprotonation, so it is ionic reactions. So we can say that carboxylic acid will undergo the reactions of due to acidic hydrogen of carboxylic acid, reaction at carbonyl carbon, reaction at the carboxylate oxygen, as well as reaction that leads to the loss of carboxylic acid, which is called as a decarboxylation. Now, if we see the reaction of carboxylic acid with sodium bicarbonate. So, in this what happened? Sodium bicarbonate is a base. So, in the base, the carboxylic acid, which has approximately 5 pKa, are very strong acid than carbonic acids, and therefore they will undergo displacement with salts and form the hydrogen carbonate or bicarbonate salts. The most reliable test for carboxylic acid is sodium bicarbonate test, which leads to the evolution of carboxylic acid. So this reaction can be used as a test of presence of carboxylic acid in the mixture. So when carboxylic acid will react with bicarbonate, it gives the carboxylate ion. This carboxylate ion formed later with byproduct carbonic acid will form. Then this carbonic acid is unstable, so immediately eliminate the carbon dioxide. The example, when benzoic acid is reacted with sodium bicarbonate, it will form sodium benzoate as a product and water and carbon dioxide as a product. So the evolution of carbon dioxide is confirmed the presence of carboxylic acid, or we can say the carboxylic acid group is reacted at OH group. Now, reaction of carboxylic acid with strong bases like sodium hydroxide, potassium hydroxide, etc. So when carboxylic acid will react with strong bases, it will form the corresponding salts. So metal hydroxide, which act as a basis such as sodium hydroxide, potassium hydroxide, and various amines, will react with acidic proton to form the corresponding carboxylate salts. If you see the example, carboxylic acid react with OH ion, eliminate the H and form the carboxylate ion, which later react with the corresponding metal and form the corresponding metal salts. Example, benzoic acid with sodium hydroxide gives the sodium benzoate plus water. Now, if we see the reactions of carboxylic acid with diazomethane. So, when diazomethane react with carboxylic acid, it will react rapidly, very fast to provide the methyl esters. So, it is a esterification reaction. So, diazomethane will react and form the methyl esters and nitrogen gas will evolve. In this reaction, the diazomethane can be written in two forms, like a first form where it is a anion at carbon and positive charge at nitrogen. Or one form where the both nitrogen will have a negative and positive charge and double bond, and carbon and nitrogen also have a double bond. Example, benzoic acid when reacted with diazomethane, it will form the methyl benzoate as a product and nitrogen gas will be evolved. Now, mechanism of esterification with diazomethane. So, if you see the mechanism of this reaction, the first diazomethane carbene ion, which is at CH2, will abstract the proton and carboxylate ion will form. Then later, this carboxylate ion will take the methyl group and eliminate the nitrogen. So, this is a mechanism, and two-step mechanism is there. Now, acid catalyzes esterification of carboxylic acid. So, when carboxylic acid will undergo the reaction with carboxylic acids in the presence of acids, alcohols, they react and form the esters. So, when the carboxylic acid will react with alcohol in presence of acid, it will undergo the esterification reaction. So, the acid are mineral acid, sulfuric acid, HCl, phosphoric acid, or organic acids. Even benzene sulfonic acid and parasulfonic acid can be used as a catalyst in this acid catalyzed esterification reaction of carboxylic acid. Example is butanoic acid when reacted with methanol in presence of sulfuric acid as a catalyst. The methyl butanoate ester of pineapple is also called this methyl butanoate is formed and water will be released. Now, if you see the mechanism of this reaction, in this reaction what happened? First acid catalyzed acid will protonate the proton at oxygen and a oxonium ion will form protonated carboxylic acid or oxonium ion will form in first step. In second step, the nucleophilic attack of alcohol take place at the carbon of this oxonium ion and an intermediate will form where the two OH groups are present. This is unstable where the geminal diol will not form, and then the proton transfer from a OH to second one and it will form the hydronium ion. Then final step, this hydronium ion will lose as a water, eliminate, and then in the final step, the deprotonation will take place and ester will form. So,